energy can be transferred using is conduction, or R, conduction, and radiation. Conduction occurs when there's direct contact. Convection is what occurs when there's temperature differences in a fluid, like a gas or a liquid, and the fluid literally moves. So whether it's a gas or a liquid, it moves. So due to density differences. I'm going to say due to temperature and density differences. If you can recall, we had done the experiment where we had some room temperature water, and we put a dropper down about this far, and we put red hot water into it, and it rose to the surface. Okay. And then we put cold blue water into it, and it sunk down below. This movement, this is essentially a current that you view. Okay, so this movement, this upward motion of warm and downward motion of cold due to density differences, that's what convection is. Okay, so then radiation is like the energy that comes from the sun, and it can travel through empty space like a vacuum. Goes through empty space. Goes through empty space, but it also goes through just regular air that's around you, because we can see objects due to light. So radiation, one type of radiation is light. Another type of radiation is thermal energy. This is all about how to calculate thermal energy transfer when conduction is involved. Okay, we're going to go through in a specific example like that, but you can also calculate thermal energy when convection and radiation are involved. The specific example that we're going to walk through in this lesson is due to conduction. Alright, so imagine that you're in a lab and you are heating up some water, but you don't just want to heat up the water, you would like to heat up a piece of metal. Okay? So you put the metal in the water, and we want to figure out, well, how much energy is that metal able to transfer? Okay, so we have it sitting there in the water, gets heated up pretty well, and after a while we take it out, and we put it into a beaker that has just room temperature water. Okay? And we measure the temperature of the water initially, and the temperature originally is, we'll say, 25 degrees Celsius. Right? And then we take the block out of the warm water, we quickly put it in this water, and we measure the temperature over several minutes. So we report our results, and in the end we find that our final temperature is 70 degrees Celsius. Right? The amount of water that's in our cup, 150 milliliters. Okay? Now, in order to calculate thermal energy, what we're looking for is how much thermal energy did the water gain, right? Now, talking about our thermal energy transfer, right? Through conduction, direct contact. Okay, direct contact is required in order for it to actually be conduction? Now, was the metal cube in direct contact with the water? Yes. So direct contact is conduction. I'm going to be asking you to make interaction diagrams. An interaction diagram shows between two different types or two different substances how was thermal energy transferred and from what to what. All right? So what goes in the box on the left is the substance that did the transferring of energy. The substance that was warmer to begin with. In this case, it was the metal cube. So we're just going to write metal. Okay. And since we saw an obvious gain in temperature here, okay, gain in temperature for the water, that's the thing, or the object, or excuse me, the substance that gained energy. That's the water. And then what you write in the arrow between is the method of transfer. In this case, it's conduction. All right, so in order to calculate thermal energy, we have to understand what the formula is that we use. So thermal energy, E equals mass times change in temperature times the specific heat of the material that is gaining energy. Okay? So mass, change in temperature, that's the final, actually absolute value, so it's going to be a positive number. Final minus original. Final minus original temperature times the specific heat of the material. All right. So this is still a new term for us, specific heat. Still a very new term. Specific heat is the amount of heat needed in joules, kilojoules, amount of energy needed to change the temperature of a substance by 1 degree Celsius. And more specifically, the temperature of 1 kilogram by 1 degree Celsius. Okay? So since specific heat is referring to something 1 kilogram, mass has to be in kilograms, temperature has to be in degrees Celsius, and that will produce for us our final calculation, and the unit will be kilojoules. Which is abbreviated, okay? Okay. Going back to this problem here, we indicated that the material that gained energy was water. And so question And that's when you use the formula. Okay, so energy equals mass times change in temperature times specific heat. I will always give you what specific heat is of the material that we're working with, and the specific heat of water, you'll probably end up memorizing this, is 4.18 kilojoules per kilogram degrees Celsius. All right, so when you work out this problem, you're just going to plug in the information that you know and leave what you don't know as its symbol. So energy we don't know, we're trying to figure that out, equals the mass of our substance, and the mass has to be in kilograms. So if we have 150 milliliters, that's 150 grams, right? And 100 by drinking chocolate milk. Starting out at grams, which is our base unit, 1, 2, 3, to the left. 1, 2, 3 to the left, ends up being 0.15 kilograms. So our mass, 0.15 kilograms, times change in temperature. Change in temperature. Change in temperature equals final minus original, 70 minus 25. Equals 45 degrees Celsius. And then times specific heat. I'm going to rewrite this. Okay, so I just rewrote that, putting the specific heat in, 4.18 kilojoules. And since we're dividing kilojoules divided by kilograms degrees Celsius, you would put divided by here, kilograms times degrees Celsius. And since we did that, this enables us to cross off the units that are repeating. Celsius, Celsius. That way we know whatever unit is left that I can't cross out is going to be our unit at the end. So once we calculate, we're going to get energy equals something kilojoules. When we multiply 0.15 times 0.45, excuse me, 0.15 times 45 times 4.18, the answer is 117.09. And that's your final answer. That's how much energy was transferred to the water from